Good morning, developers. Let's start developing. My name is Veko, and today we're going to be solving the eighth task of this year's Advent. Let's take a look at what it is. You barely reach the safety of your cave when the well smashes into the cave mouth, collapsing it. Another exit to this cave at a much greater depth, so you have no choice to press on. Great! As I said yesterday, we get to search for an exit from a maze. As your submarine slowly makes its way, this is going to be most likely a long video, knowing that how long it takes to basically get everything done. Let's get to the details. As your submarine slowly makes its way through the cave system, you notice that the fourth digit 7 segment display. Yeah, 7 segment display is the one that you get right now on your air conditioner and things like that. When we have the numbers displayed in 7 segments, um, each digital, yeah, this is a 7 digit segment display. So this is 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, a 8, and a 9. Okay, yes. I must have mixed number on each display. The wires are mixed separately for each digit. Ah, no. So, yeah, I guess we won't be solving a maze after all. Uh-huh. Uh-huh. We have a puzzle where we are given some inputs and we will need to map those inputs to the correct inputs. So we're gonna need some kind of a game of deduction. Let's take a look at the input first. Oh, this is ugly. Yeah. Let's see what the input. For each display, you watch the changing symbols for a while, make a note of the all 10 unique signal patterns you see. All 10 unique signal patterns, which means that these are the values for 0 to 9. Yeah. So, yeah, for example, we can see that this must be an 8 because everything is lit up, but that doesn't tell us anything. So, yeah, we have kind of an enigma problem, let's say, because that's what Enigma did, was basically just simple letter substitution, only it did it in a much more complicated way. So we have some kind of a, let's call it a substitution cipher that we need to decode. Yeah, and for example, yeah, the AB1 here has to be the one because that's the only one that only has 2 segments lit up. So either A is actually C and B is actually F, or the other way around. And I guess we will need to find out until we get to some kind of a contradiction. So we have all the inputs. These are all the values. So there is a 0 through 9 here. And then this is the results that we are given. And we have 5, 5. These two are the same. CDBAF, CDBAF, and these two are the same. So the one thing that I will do is basically sort this out so we don't think that this and this are different. And it's actually given a CFBCAD right here, and this is actually that letter. I have no idea. So we have 10, then a pipe, then 4. So each of these is an independent format, so to say, an independent task. We will need to solve each one separately. Focus on the easy. Oh. Let's let's see. Let's actually deduce this. I want to be sure. So zero has one, two, three, four, five, six values. So for six we have it could be a zero. For two it's a one. One, two, three, four, five. Five it's two. Two, three, four, five. Yeah, makes sense. Only three, four, four. Yeah, four maps. One, two, three, four, five. Five maps. Five. One, two, three, four, five, six. Three. No, three is seven. Four, eight is seven. Nine. And we need to find out the one, four, seven, and eight. You know what? We don't actually need to decode anything for part one. So, looking at the input, I guess that we will need to find some kind of array to parse this. So, we are starting, and then we have the letters A to F multiple times. And then, no, more than one time. It's actually more than two, but less. Alright, and then we have what am I doing? A, B, C, D, E, F, G. Yeah, that was stupid of me because we have a G actually. I was thinking of hexadecimals and those are 1 to A to F. So we have 7, not 6. So we have a space and then we are basically repeating that exactly 10 times. And then we have a literal pipe. And then we have a space, actually a space. And then we have again an A through G more than once. And we have that exactly 4 times. Seems that we're matching everything, only our groups are misaligned. So we have a repeating group like this. So this means that we are only extracting the last value and we want to extract the whole thing. So that means that we can turn this into a non-capturing group. So we're not capturing that. And this as well. And then we need to capture the whole thing. Yeah, that whole thing. And here the come on. I'm looking for the dollar. This looks complicated. Hmm. On the other hand, all the pipes are aligned. Yeah, because we have all the tens on the all 10 signals on the left side, and even if they have different lengths, the total length has to be the same. It's actually the 2 plus 3 plus 4 plus 3 times 5 plus 3 times 6 plus 7. So it has to be plus the space. It has to be like that. Let's do that. Let's take one of line of this and let's put value and then value dot substring. Well, start from 0 and take 30. That's way too much. And now we're gonna just guess it until we get to a specific. Take 40. No. Take 50. 1, 2, 3, 4, 5, 6, 7, 8. So we're cutting off here, so we need this much. Take 60. And okay, now we just need to go to back. Take exactly 58 DGC. And now if we split this on a space character, where we're getting the exact. For the first one, we are getting 10. The first one is CBDEF, CBGEF. The last one is DGC. This one is a 7 because that's the only one. So we have that, and then we have the 5, and then we actually need these. So that's the way the formula for the digits and the formula for the actual values. Well, we will need to start at, let's say, 60. It's better to go low than high because then we can really add it, count what we are missing. So we need to go one more, 61, and split on a space. And we have EAD, EAD, and we're ending with that. Yes. So I think I'll go around about it this way. So for my input parsing, yeah, let's start with the example. No, yeah, this is bold, so bold won't pass along when we're pasting it, but we will need to do this. So this is our demo. And we will need to create input lines. Those are the lines. Map. And I'll create an interface that says basically a mapping. Let's call this. And we will have digits, which is a string array actually. It will contain and value, which is another string values. So we're gonna map the lines and that will go into the result and what we will do. Now we're just gonna do some copying. That's this one. And this is line values. Actually, we can do some more things and just return this. This is digits. This is one right there. And this is a mapping array that we're actually our input is not done. number array, it's O. And looks okay because is everything okay? Yeah, it is. Let's run this. Yeah, see. And now, the first part, I think it's rather silly because we are asked only for the easy case. So only for the digits that have either a length of 2, 3, 4, or 7. And we're going to do that, well, in the stupid way possible. So input.map, we're going to for each mapping dot values filter the value, not that one. If the length of the value is in the, well, single values are either 2 or 3 or 4 or 7. 2 or 3, 2 or 3 or 4 or 7. Yes. So if the length of the value is included in the singles array, yeah, to be honest, this looks much more complicated than it is because we're just going through all the mappings and saying you don't count, you count. You don't count, you, I guess, count. This is a 7. Yeah, so basically we are mapping this line to the value 2. And by mapping, we're filtering this one and this one. So we're filtering this array into an array of 2 elements and then just taking the length. So we're basically mapping this to an array of numbers. And then we're just gonna reduce of it to get the sum because of reasons JavaScript does not have a sum function, but you can implement it as it. And that is the result. And we're just gonna return. Yeah. Explained like this, it looks trivial and it kinda is. So if we're correct, we should get 26. Yeah. I have a feeling that the second part will be a bit more complicated, but let's see. I think that we will have to play a little bit of Sudoku. For the first part, the result is 445. Let's see. Yes, that's the right answer. Of course it is. Through a little detection, you should now be able to determine the remaining digits. Of course. Consider again the first example above. The careful analysis, the mapping between single wires and segments only makes sense in the following configurations. So the unique signal patterns, blah, 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 is that. So the value is 5353. Yep. So we're gonna have to work quite a bit harder for the second star. As I said, we just need to sort everything we're doing here. in order to remove ambiguity. So we need to make sure that this one and this one are displayed in exactly the same way, in the canonical way, so to say. And that canonical way should be A, B, C, D, F. And you can say that here we didn't even use the digits. So after we split it, we can map them, and we can map digit with digit dot sort. Why is this an issue? Hmm. Split on an empty string, then sort, then join on an empty string. Yeah, we cannot just sort a string, because how do you sort a string? But you can sort an array of characters, and that is what we actually want to do. Let's see that we didn't. What are you expecting, and where are you expecting it? You're expecting this. Let's run this again. It should have absolutely no effect on what we're doing, because we're basically only using the length. We didn't use the digits at all, and from the values we only used the length of the thing. But you can see that now we have everything in a format that we're gonna say canon. We're gonna call canon. Yep. So let's see if we can make an algorithm out of this. We can actually, let's do some kind of let result equals 0, return result, and then we're gonna do a for loop for mapping of. Now for each mapping, what we want to do, ping dot digits dot find, not that, but where digit dot length equals not 1 but 2. That's the one. And similarly, we can get 4. We can get the 7. Actually, 4 has 4 and 7 has 3. And the 8 we don't need. The 8 basically does not give us any information, because the canonical form of the 8 is always, and I mean always, A, B, C, D, E, F, G. Everything is lit up. So if we are getting the information that everything is lit up, we are not getting any information. But let's see what the issue is. What can we use it to deduce this? So one, uh, so now we will need to do some logic. So one, and let's look at 1 and 7. 1 and 7 are differing in only two places, in only a single place actually, this line. So the one that exists in 1 in 7 but not in 1 is the top line. Yeah, so we can basically from this top line top is, yeah, we're not gonna split. We need to find that one, the one that is, and actually we can, yeah, we can run a split on this because we want to have them set no split on an empty string. So now we have an array of digits, of line segments, so to say. Let's debug this. So we're going to break after the first iteration, and we're just going to log 1, 4, and 7. Yeah, BE, BDE. So with this is 1, this is 7, and it's obvious that D is the top segment. Find segment where 1 dot includes segment not. Find me the segment that is in 4, but it's not, but it is 7, but not in 4. And this says that's segment D. So we have the top segment. And similarly, if we look at, hey, take a look at how this looks when I'm doing alt tabbing. When we're looking at it in detail, we are not able really to see the numbers, but when you're looking like this, the numbers are kind of, yeah. So the 4, we have the top left and the middle. Let's call that mid left, B and D. So we can get the mid left is 4 that are in 4 but not in 1. And when we're not going to do a find, we're going to do a filter here and log the top and the mid left, because the mid left actually consists of 2 segments. It's C and G, and that is correct. So now we have our top segment. Take a look. So we know where this is and we know where this is. And we have a 0. Now I want to look at the ones that have 6. And that's the 0, the 6, and the 9. The 6 doesn't have this one. The 9 doesn't have this one. So if we write a 1 and a 7 and a 3, we will have this part. And this part is only present in the 9. And the 8, of course, but we're, yeah. So we know which one is 1, we know which one is 4, we know which one is 7. And if we jump all of them together, if we write a 7 and a 4, basically, we're getting 1, 2, 3, 4, 5 items that should be included. Can we do that? Yeah, we can. Yeah. So from the ones that have 6 segments, we need to find the one that has all the segments in 1, 4, and 7. Actually, all the segments in 4 and 7 only. That's enough. And an extra segment. Well, of course, it will have an extra segment because this is P5 and this is 6. So, yeah, for now, let's ignore this. So, 6 segment thingies are the where that have a length of 6 sixes. And I'm gonna put an S in front of this because this is not the digit 6, this is the 6 segmented one. And I will split those. And after I split them, so this is right now, no, 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 no. We're not finding, we are filtering. And we're not splitting it, we're mapping it to a split. Digit. Split. Technically, this is an array of arrays. And let's be conservative once more. And just look. So you can see that we have, so if you join the 4 and the 7, we have B, C, D, E, G. B, C, D, E, G. B, C, D. This one doesn't have a B, so this is not a candidate. B, C, D. This doesn't have a C, this is not a candidate. So this is the 9 because it had B, C, D, E, G, and that means the F is the bottom one. Actually, yeah, I will leave this. We have the top segment. Let's call it top. So this is the 6s. Out of the 6s, we are looking for the 9. The 9 is the 6s. Find the one that, totally not that. Find the one. So it's not a segment, this is a digit. And we will need to join the 4 and the 7. Actually, we can do it the other way around. So 7 dot includes for every segment in the digit. Seven dot includes segment and no. Yep, the other way. 7 dot every item in the 7 is included in the digit. Yep. And same goes for the 4. Log me the 9. If I'm correct, it should give us the BCDEF and so on. Yep, it gave us the 9. So the 9 is the only 6 segment number that has all the digits, all the segments in 4 and 7. And it means that we can get bottom segment, that's 1, 9. From the 9, find me a segment that is not included in the 7 and not included in the 4. From what are analysis, BCEG, BCDEG are those, so F will be the bottom segment. We deduce that the top segment is D and the bottom segment is F. Let's write it out like this. And we don't at the moment. Top is D, bottom is F. So we have the top and the bottom. Once we have the top and the bottom, what else can we do? This segment now, this is the only segment not present in the 8. Because right now we have no power to distinguish between B and D. Of course we don't, because they are either both missing, as here, or here, or both present, like here and here. So we need to have a situation that's where we have a difference. So yeah, this segment can be found out if we compare 9 and 8. So we need the 8 after all. That's 7. Low left. I will call them low left and high left. That's 8. Find segment not included in 9. And from what we had, DF, the only one not included in 9 was A. So that means that low left is I need a dollar. Actually, you know what? I'm gonna go fancy. Space, space, space. And then I'm gonna do top segment, top segment, top segment. And let's copy this over. Yeah, that's I just need the 8 because that one has everything. Like that. Oops, sorry. From here on in. And now we need to get rid of the 9 by 9. Let's paste this here. Yeah, like that. Paste here, and this will actually be top segment, top segment, top segment, and top segment once more. This will be a question mark, 1, 2, 3, 4, question mark, question mark, and this is dollar 4 times. Your mark. And here we will have low left segment. Yeah, let's see our display now. Yeah, looks much better. We just need to remove this empty line because we don't actually. So those are the things we know. We know this, we know that. Let's remove the question mark because I think that are much visible. Yeah. So those are the parts we know. The rest of it we don't. Now what we can do? Will the 0 help us? If we join this with a 1, because these two lines are a 1. So if we add to this the ones that are present in the 1, the only one that's not visible here will be the top left. So let's do that. So if we take the ones we know, we create an array with the top segment, the bottom segment, the lower segment. We don't run a filter, and we add the 1. I don't have a smart name for this. We will have something. Oh, do we know where the 0 is? Of course, we don't want to know which one the 0 is. The 0 is in the group with 6 and 9, so we can only get the 6s. We know which one the 9 is. So we have the 6 and the 0. So we already got the 9. So that means in the sixes, now we have only a 0 and a 6. Yeah, we can do a simple thing like this. Filter out the 9, so we have the 0. Let's just console this to see if we are not running some weird issues with the quality. 0 should have 2 elements. And it's not the 0. This is the 9, the 6 segments with the 9 removed. So if once we do that, if we are saying find me the digit when 1 dot every segment is included in the digit. That's there, 1 more. So because if we look at the 1 and we compare it with the 0 and the 6, 1 is contained in the 0 but not contained in the 6. That means we get the 0. Okay, let's log the 0. In our scenario, I think, well, let's see. Yeah, that one is the 0 because that's the 1. So now when we have the 0 and we have what we already deduced, the xxx or whatever, so what we can do is basically find me the segment, 0 dot find the one, the segment that is not included in the xxx. Let's see if that is a single thing, and of course it will be a single thing, and it should not be one of the ones we already found. That's G. Yay! So our G is the high left. Is that? I'm just gonna call this helper. Let's take a look at this. So we instead of this, this is high left. Okay, now we're getting somewhere. And now it seems kind of obvious. If we add this and 1, we are left with something that is only missing the central. So we can compare with the F and get the center part. Helper 2. see if this makes sense. Yeah, we got C. So now we have G and C, and we just need something to discriminate between the ones. So 2 and 3 both have 5s. Let's see. 6. We actually know which one is the 6, because the 6 is the one with the 6s. That is not a 9 and is not a 0. If it has 6 digits and it's not a 9 and it's not a 0, then it has to be that. And yeah, I don't think this is correct. High right segment. So the helper 2 has these 3 and these. No. High right segment. The one that's in the 1, but it's not in the 6. Yeah, that is simple. 1, find segment that 6 doesn't. Oh, we need to find. Yeah, that's right. And now we can just more or less continue with this. Top, bottom, low left, high right, center segment. We have 1, 2, 3, 4, 5, 6 segments, and this is helper 3. And now we can say low right segment is the one that's not included in this thingy, whatever it is, but it's included. And after a lot of totally custom coding, we managed to get our mapping. So this is the mapping that we want. And now comes the, so to say, easy part. So we have the values. Mapping dot values dot. So actually now we don't need the segments at all. What did we do this for? We have a variable called 1. Actually, we have a variable called 1, called 4, called 7, called 8. We have a 9. Let's do this. 0, 1, 2, 3, 4, 5, 6, 7, 8. That's all there is. And let's see, do we have a variable called 1? Yeah, we do. We have a variable called 4, a variable called 7, a variable called 8. We have a variable called 9, a variable called 0, a variable called 6, and that's all there is. But that means we that with these variable const 2 equals, well, we just can construct it now. 2 consists of the top segment, high, high right segment, center segment, low left segment, and bottom segment. Dot sort. And join. Actually, yeah, let's have it. 3 is, yeah, not this, but it's top, high right, center, low right, bottom. So we have 2, 3, and then we also 5. That's top, high left, center, low right, yeah, low right, and bottom. I don't think I made any changes. 3 has, let's see, high right, low left, high right, low left, high right, low right, high right, low right, high left, low right, high left, low right. Yep, we are done. And now we can do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, 0. And we're just enjoying everything. And these are the actual digit values. Let's just log them. Yeah, so that is 0, 1, 2, 3 in the canonical form, which means that now mapping dot values, we totally know how many things are in values. We have exactly four things in values. So in order to get the number, we will need to get the first one, multiply it with 1,000, with 100, with 10, and with 1. So, and to just get that, we will need to let's have this in a different structure. Actually, we can still use digits dot index of. Yeah, we can use index of. Index of mapping dot values of 0 times 1,000. That's the value. Plus, yeah, finally on this task, Copilot came through because it's quite smart in discerning pattern. So that will be the value. And then we can just say console log the value. And if we are correct, we should get 53, 53. Actually, I have no idea because this is some or the original example, but let's use that. 53, 53. Let's go back to the demo example and let's run it, but we will need to remove this break so that it transfers everything, and instead of logging the value, we need to do this. So we return the total sum. 61,229. Yeah, and we are decoding all of this successfully. So I will either remove that fancy console log. I'm just gonna comment that. To be honest, it looks too beautiful to delete. In production code, I wouldn't have such qualms, but here I might want to show off eventually. 61,229. Let's go back to the huge input. Copy everything, paste everything, and let's try it on for size. You can see this was a much more logic-oriented puzzle than anything else because the code is almost completely hard-coded. Yay! This was great. The processing is fast once we knew what to do. So this was not a case when the code was simple, but the processing with optimization was needed. The code is terribly convoluted and is terribly specific. So we're getting the 6, not the 9. I guess there are other ways to go around it. Through it, I started with something and then that paid out and I continued with it. And you can see that at the bottom it was relatively simple, if a bit convoluted with helper 2 and helper 3. And after we had all the segments, it was literally trivial to do everything we wanted. On a side note, I read about a bit on the 7 task, the one that I totally brute forced, and I was only able to do so because the input was suitable. But as you can see, I was playing around with it yesterday. Come on. Yeah, this is the huge input. I was playing around with it yesterday, and from what I saw and from what I glimpsed, this can be solved in a much more simpler analytical way. Because for the first one part, the solution will always be the median value of the numbers. So we only need to find the median, which can be O of n operation if you use a fancy algorithm, or it's over n log of n if you use the sort method. And for the part two, the solution is always the average of the average value. Of course, we might get some rounding with the average, but it's right at or the nearest one to the average. That can be mathematically proven, but I will not going to do that because this variant also runs fast enough. Let's just try it once more. Without debugging for day 8. And we can see that the whole processing is 5 milliseconds. And so this one, the 8th task runs amazingly fast with a completely custom algorithm. So in effect, If we had a chip factory, we could do this as a system on chip that will automatically decode everything. And this will be amazingly fast. But on the other hand, you can see that this is an amazingly custom algorithm that depends on a lot of assumption of what the digits look like and everything. So there's nothing generic about it. On the other hand, this one is totally generic. It just rams everything together and tries to find the solution, but it can be a bit on the. So we have 16 stars so far, and I will say thank you and see you tomorrow. Bye.